Hello students, welcome back. Let us learn one more concept today. Let us take two identical spheres. I am considering two identical spheres. Identical means they are made up of same material and they have uh, same size. Okay, if you look at this, they must look identical. Okay, so two spheres. And these two spheres are separated by certain distance. Let us take that distance as r. Okay, distance of separation between these two spheres, let it be r. Okay, r is the distance of separation, and both of them are charged. Okay, even though they are identical, let us take the amount of charge on both on each is different. Okay, so on this the amount of charge is q1 and on this charge is q2. Okay, so two identical spheres separated by certain distance, and on first sphere the amount of charge is q1 and on second sphere amount of charge is q2. And of course, due to the charge there must be some electrostatic force, right? The nature of force depends on the polarity of charge anyhow. So I am considering general case, therefore there will be certain amount of force between these two spheres. Okay, let it be F. The electrostatic force between two sphere when they are separated by certain distance r is F. Okay, so initially they are separated. Now in the next step I am just bringing these two spheres together. Okay, so I am considering these two spheres together. That means these two spheres brought in contact. Initially they are separated. Okay, later they brought in contact. That means you can consider that two spheres like this. Both the spheres are in contact. That means what is the separation between them now? The separation is 0. Okay, they are in contact. Now what happens to the total charge? Now what happens? If q1 is greater than q2, charge will flow from q1 to q2, and if q2 is greater than q1, charge will flow from q2 to q1 till the amount of charge is same on both, right? Or if you consider this as a whole, or if you consider this as a single body, now the total charge can be written as q1 plus q2, correct? No? So on first sphere charge is q1 and on second sphere charge is q2. Therefore when they are in contact, the total charge can be written as q1 plus q2. Okay, yes. Now I am again separating these two spheres. Okay, initially they are separated by certain distance r, right? So again after contact again I am separating them to same distance of separation. Okay, again I am separating these two spheres to same distance r. Now what is the charge on first sphere and what is the charge on second sphere? As I said, these are identical spheres, right? Therefore when you separate them, the amount of charge on both the spheres must be same. That means total charge is q. Therefore this q has to be divided equally between these two spheres, since these two spheres are identical. Therefore on the first sphere the amount of charge will be q by 2, and on second sphere q by 2. If you add these two, q by 2 plus q by 2, you must get the total value q. Hope you got it. Okay, yes. Now in first case the force is F, right? What about force in this last case or third case? What about the force? Whether it is same as that of F? No, this force will change because the value of charge, it is changed, right? So in first case amount of charge is q1, second case is on second sphere it is q2, but here what happens? Amount of charge is changed. So here q by 2, q by 2. So when charge changes, force must change. Even though separation is same, separation remains same, but the value of charge is different compared to that first case. Therefore here force changes, therefore I will take that force as F dash. Okay, so in this particular case force is F dash. Now you may get certain questions based on this concept. Sometimes they may ask you to find the value of f dash by f, or if they have given the value of f and amount of charges, then you may need to find out value of f dash. What is the value of f dash? Okay, like this they may ask certain questions. So for that we can use some shortcut formula. Okay, so how to write that shortcut formula? So in this particular case we can write expression for f, right? Expression for Coulomb's law, force, Coulomb's force. You know, if you know the value of charges and if you know the distance of separation, directly we can write, that is k into product of charges q1 q2 divided by square of the distance of separation between them, right? So this is the expression for force in first case. Now what about expression force in this last case? Now what is the value of k remains same? What about q1 and q2? Yes, that will be q by 2 q by 2, right? So we can write q by 2 q by 2 charges divided by distance. Distance will be the same, so that is r square. That means we get k q square divided by 4r square, correct? No, if you just simplify this, you will get it as 4r square. Now you can find out this f dash by f, right? What you have to do? Just divide this equation 2 by equation 1. Just divide 2 by 1. So what do you get? F dash by f, that is equal to, if you divide, this k get cancelled and this r square value get cancelled, and you left with this q square and 4 q1 q2, correct? No, just look at this. Okay, q square divided by 4 q1 q2. But can you write this q square in terms of q1 and q2? Yes, obviously you can write. Why? Here it is, the total charge q is nothing but sum of q1 and q2. So I am writing this q square as q1 plus q2. Therefore finally we get f dash by f, that's equal to q1 plus q2. This q1 plus q2 whole square, because q equal to q1 plus q2, you already know that, right? Divided by 4 q1 q2, 4 q1 q2. So this is the shortcut formula to get the value of force, or if you want to get the value of ratio of force, then you can use this equation, right? So hope this will be helpful for you. Okay, so in the next video let us learn one more shortcut concept. Okay, yes, thank you.